Welcome you all. Dear students, the previous class we are discussing about corrosion theory, theory of corrosion, and then types of corrosions, and factors. Then remaining is prevention or corrosion control. Now theory is over. There are two theories. The previous class we are discussing about. There are two theories: electrochemical theory of corrosion, then differential aeration theory of corrosion. Now types, there are three different types: differential metal corrosion, waterline corrosion, and then pitting corrosion. Factors, there are 5 important factors we have discussed. Then remaining is control. Now corrosion control, today just I am going to discuss in details about corrosion controls. Corrosion control. Corrosion control. The rate of corrosion can be controlled by using different techniques. The rate of corrosion can be controlled by, there are two different techniques. The one is protective coatings. Protective coatings is one of the technique. Now coating of metal on metal or metal on alloy, these techniques, the protective coatings, you can easy to control the rate of corrosion. Now under protective coatings, there are 3 subheadings. One is organic coatings, then inorganic coatings, metal coatings. Now these are the different methods to control the rate of corrosion. Likewise, the second method, cathodic protection. Now what is meant by cathodic protection? Generally the corrosion takes place at anodic region. Which metal act as anode? That will undergo oxidation, that metal undergo corrosion. Now that base metal itself made it as cathode. How is possible? By providing electrons by using external source, it is possible to make it as cathode. The base metal or anodic metal itself made it as cathode. That techniques are cathodic protection. Now cathodic protection can be achieved by two techniques. One is sacrificial anode method. And second one, impressed current technique or method. Impressed current, by applying a current can make it as cathode. Impressed current technique or method. Okay. Now these are the different techniques to control the rate of corrosion. Now as per syllabus, just organic coatings. Now generally we are discussing about paints is coming under paints are coming under organic coatings. Now inorganic coatings are two. One is anodizing and phosphating. Now these are all the different techniques to control the rate of corrosion. Metal coatings, metal on metal, there is no reaction here, only the metal can be coated on metal. These are metal coatings. Inorganic reactions takes place, this is an organic. Metal coatings, there are two types. One is galvanizing and tinning. Now these are all the different techniques to control the rate of corrosion. The first technique is protective coatings. These are all coming under coating methods, that is protective coatings. Now these two are, the base metal itself made it as cathode, that is why they called as cathodic protection. Cathodic protection means the base metal itself made it as cathode by providing electrons by using external source. Now if you made it as cathode, that metal does not undergo corrosion. It is free from corrosion. That is the one of the technique. That can be achieved by two techniques. One is connected to the sacrificial anode method. Anode metal is connected to iron, and by applying electric current they can made it as cathode. I will take up one by one. Now just I go for first one, anodizing. Anodizing, galvanizing. These four techniques is important as per your syllabus. Just you have to concentrate on what is meant by anodizing, what is the process, and what is meant by galvanizing, what is the process, how can done galvanizing process, and then what is a sacrificial anode method and impressed current method. Now these are all the general methods to control the rate of corrosion, out of which you should concentrate on anodizing, galvanizing, sacrificial anode method and impressed current method. Now I will take up first one, anodizing. Anodizing of aluminum. Anodizing of aluminum. First, you have to understand that what is meant by anodizing. Anodizing is the process of coating of anodic metals like aluminum, zinc, magnesium, chromium, etc. These metals are coated on the surface of iron to control the rate of corrosion. The anodizing is the process of coating of anodic metals like aluminum, zinc, magnesium, chromium, etc. Any in the galvanic series of metals which are the anode metals on iron above the series. These metals are anodic metals. These metals are coated on iron surface to control the rate of corrosion. That method is called anodizing. The example, anodizing of aluminum. The anodizing of aluminum takes place due to electrolysis reaction. Electrolysis reaction. Anodizing of aluminum takes place due to electrolysis in presence of suitable acid electrolyte. In presence of suitable acid electrolyte and moderate temperature and moderate current density. Moderate temperature and moderate current density. By applying suitable temperature and suitable current density, now you can apply that electrolysis reaction takes place. Aluminum metal undergo electrolysis in presence of suitable acid electrolyte at moderate temperature and moderate current density. That undergo electrolysis, it forms the result, the formation of oxide layer on the surface of aluminum metal. For example, this is an aluminum metal. Now they are deep inside the electrolyte. By applying a suitable temperature and moderate current density, when apply that, the aluminum surface undergo oxidation, it forms a oxide layer. Now it forms a oxide layer. Now that will form a oxide layer. That oxide layer is an insoluble in water, but outer part of the oxide layer is porous. It has the outer surface of the oxide layer, it has porous. It has a small porous. Then it again they undergo corrosion. To control that porous or sealed, this porous can be done by treating with boiling dilute sodium dichromate solution. Sodium dichromate solution. By treated with this boiling dilute sodium dichromate solution, the porous can be sealed. Then it become insoluble in water. That aluminum undergo oxidation, it forms a oxide layer. That oxide layer is insoluble in water, but it has porous. Porous can be sealed by using boiling dilute sodium dichromate solution. Then it become insoluble and non-porous. Insoluble and non-porous, automatically rate of corrosion is controlled. Rate of corrosion reduces. That is the process that is called anodizing of aluminum. Okay. Then I go for galvanizing. Galvanizing is the process of coating of pure zinc metal is coated on the surface of base metal. Next one is galvanizing. Galvanizing is the process of coating of pure zinc metal. Pure zinc metal is zinc metal is coated on the surface of iron. Pure zinc metal is coated on the surface of iron, that is called galvanizing. The process of coating of pure zinc metal on the surface of iron. Suppose on the iron surface, the pure zinc metal is coated on the surface of iron, that is process is called galvanizing. Now galvanizing, what is the process? Now process of galvanizing is, first the article to be protected from corrosion. Which metal or which article or which object is required to control the rate of corrosion? That first treated with dilute sulfuric acid, organic solvent. First treated with organic solvent. First treated with organic solvent. Now the galvanizing is the process of coating of pure zinc metal is coated on the surface of base metal to control the rate of corrosion, that is called galvanizing. Now galvanizing process can be carried out, first the article, which article you want to coating of zinc or galvanizing, that object should be first treated with organic solvent, because organic solvent if you treated, you can easy to remove the organic matter on the surface of object. Suppose it containing any oily layer or greasy layer, that can be removed by treated with organic solvent. After that they treated with dilute sulfuric acid. Dilute sulfuric acid. The dilute sulfuric acid is treated to remove any oxide and scale formation on the surface of the object. Suppose already is there any oxide layer or scaling is takes place, that can easily removed by treated with dilute sulfuric acid. If containing acid layer on the surface, then corrosion rate is very high. Therefore, after that to remove the acid layer, first then treated with water, wash with water. After wash with water the surface, again it undergo corrosion easily when water content is there. Therefore, finally that should be dried. Now that is the process. Now before galvanizing, the object should be cleaned properly by following methods. If containing any oil and greasy layer, that should be removed by treated with organic solvent, and then if containing any scale and oxide layer, that can be treated with dilute sulfuric acid to remove that, and then to remove the acid layer wash with water. To remove the water content on the surface of the object, that should be dried. Now that object is ready to galvanizing. Now that object is ready to galvanizing. After that, you take pure zinc metal, heat it to 450 degrees centigrade. Then it become molten state, semi-solid state, molten zinc. Now it become molten zinc. The pure metal of zinc is heated to higher temperature at about 450 degrees centigrade. The zinc metal is converted to molten zinc. That is a molten state, semi-solid state. It is not a liquid, it is not a solid. That is intermediate state, that is molten state. Then the object you already cleaned properly by following technique. That object should be immersed inside the molten zinc. The zinc layer is coated on the surface. To get the uniform thickness of the zinc layer, that should be passed through 2 rubber rollers. Now that should be passed through rubber rollers. The excess of zinc layer is removed and uniform thickness of zinc is coated on the surface of the object. When zinc is coated on the surface of the iron, that is easily control the rate of corrosion. That method is called galvanizing. Now galvanizing, anodizing is over. Then I go for cathodic protection. Okay. Now then I will go for cathodic protection. Now cathodic protection means, it may ask in the examination what is meant by cathodic protection. You should write the definition of cathodic protection, and then you are going to explain sacrificial anode method and impressed current technique. Now I take up first one, sacrificial anode method. Now first you have to understand that what is meant by cathodic protection. The base metal itself made it as cathode by providing electrons by using external source. Then we can achieve the cathodic protection. Now cathodic protection can be achieved by connected with either anodic metal to the iron and by applying electric current. Now these are the two different techniques to made it as cathode. The base metal itself made it as cathode by using these two techniques. Under that first one, sacrificial anode method. Here I will take this iron metal, there is an iron metal. Now when iron metal is connected with a mesh of a zinc metal, a mesh of zinc metal is connected to iron metal. Okay. Now this is zinc metal, I connected with iron. What happens here? Zinc is more anodic metal to iron. In the galvanic series, in the electrochemical series of metal, iron is less negative potential than zinc. Therefore, zinc is always act as anode when you connect it with the iron. Now, zinc act as anode, they undergo oxidation, that will undergo corrosion, but iron it become cathode. How it made it as cathode? By providing electrons. Now electrons always transfer from anode to cathode. Now electrons are transferring from anode to cathode, iron metal become cathode and zinc act as anode. Now electrons it undergo oxidation, the electrons are removed, they are passed through anode to cathode through external wire, then this is act as anode, this is act as cathode. Now iron is free from corrosion. That method is called sacrificial anode method. Why you call it as sacrificial method? Now zinc sacrifice its life to prevent the corrosion of iron metal. That's why they call it as sacrificial anode method. Now zinc metal when you connect it to iron, anode the metal actually is a separately suppose you take iron separate, zinc separate, this also act as anode, this also act as anode because it has high negative potential. When connected each other, then iron become cathode, zinc become anode. Zinc undergo oxidation, that will undergo corrosion, but iron metal it is free from corrosion. That is one of the simplest method to control the rate of corrosion by connected with zinc. Zinc is low coster than iron metal, therefore you can easily connect it each other, then automatically it is free from corrosion. That method is called sacrificial anode method. Then I go for the impressed current technique. Now in the impressed current technique, in this method, the base metal, which metal you want to prevent from corrosion, that can be made it as cathode by applying electric current in the reverse direction. Now corrosion current can be nullified by applying electric current. This is the method, just you can see that. Now I go for B, impressed current technique. Impressed current technique. Okay, impressed current technique. In this case, the always in case of buried pipelines, now water supply, the iron pipe undergo corrosion, that can be made it as, is not unfeasible, but it is one of the method to control the rate of corrosion. Now iron metal, they are buried inside the soil. To apply the current they required, there are two electrodes. One is a reference electrode. Now the iron metal itself made it as cathode by connected to negative terminal of DC or positive terminal of DC. To made it as cathode, that should always connect it to negative terminal of direct current. Now this is a direct current, suppose. Now is a positive terminal, this is a negative terminal. Now negative terminal is connected to iron. Now as you can see that to pass the current they required, there are two electrodes. Now this connected to this one, this is a negative terminal, that is act as cathode. Okay, the base metal, which one you want to prevent from corrosion, that should be made it as cathode. To pass the current, one more reference electrode is required. That reference electrode generally either may be graphite rod or silicon iron alloy. Now this is reference electrode. reference electrode. Now reference electrode, it may be a graphite rod or silicon iron alloy. This generally they are used these metals as a reference electrode to pass the current. Now this also just buried inside the soil and connected to terminal. Now this is a positive terminal, this is act as anode, okay. Now by apply the electric current. Now this is the buried pipe, buried iron pipeline inside the soil. Now this is the soil. Now apply the electric current. What happens here? In this method, you can easily to achieve the made it as cathode, the base metal, iron metal can made it as cathode when you connect it to the negative terminal. Now by applying electric current, the electrons are transferring from anode to cathode. Now cathodic protection itself says, the cathodic protection means the base metal can be made it as cathode by providing electrons by using external source, either by connected with the negative metal or anode metal. When electrons are transferred to iron, they made it as cathode in this method. In this method, by applying electric current, when you connect it to the negative terminal of DC, now this iron pipeline, they act as cathode and apply the electric current by using a reference electrode, then electrons are transferring from anode to cathode. Now electrons transferring from anode to cathode, this is free from corrosion, does not undergo oxidation. Now iron metal with 24 into 7 into 365 days, suppose if you apply the electric current, then does not undergo corrosion. You can easy to control the rate of corrosion by applying electric current. That method is called impressor current techniques. Now this is about corrosion science. Now in the corrosion science, we have studied about theory of corrosion, types of corrosion, types of corrosions, factors influence the rate of corrosion, either increase or decrease the rate of corrosion, and control of corrosion and control. Now these are the 4 subheadings coming under this chapter corrosion science. Now I already studied theory, types, factors and control. Now these are all the different techniques of controlling rate of corrosion, out of which you should concentrate on anodizing, galvanizing, sacrificial anode method and impressed current method. Anodizing, you have to write that what is meant by anodizing and what is the process. Galvanizing definition and process, same thing, sacrificial anode method and impressed current technique. Now these are all the methods to control the rate of corrosion. You can easy to control the rate of corrosion. Corrosion is always happen. Okay, that's about corrosion science. Thank you.